Hi everyone. So, if you remember in the last class, I said that I will bring one question for you all related to the concept that we were discussing. I think you all can see this figure, and from here, you all can guess about what I am talking, right? So, I have said that there is a diagram given in the NCRT in which some zinc granules are added to the, okay, I've written water by mistake. So, this is acid. So in this acid, let's say it's HCl-H2SO4, any acid, okay? So if we are placing some zinc granules in the acid, then what is going to happen? We have discussed that. Then if you remember, I told you then that I will bring one question which is related to the same concept but with a new approach. So the question is, what do you observe when this figure is there? What are you observing? What is happening here? This is the question. So what we can see is zinc granules are there, and you all know that zinc granules means this is a metal, right? You're having some metal pieces. So metal is kept in the acid, and you all know that in the beginning of the chapter I told you when I was teaching this topic that whenever you will add metal to the acid, it will always release H2 gas and a metal salt will be formed, correct? So this time we are having zinc, and let's say I'm taking the acid H2SO. So when you are adding zinc, which is a metal, to the acid that is H2SO4, it is going to give H2, that is for sure, right? And then whatever is remaining, just write it down. What else is left? Zinc is left and SO4 is left, that is sulfate, right? So it will give ZnSO4. So because Zn carries +2 charge and SO4 carries 2 minus charge, this is the compound formed, which is a salt, right? And H2 gas is evolved here. So by this, we got an idea that this is the reaction which is taking place here. That means hydrogen gas will be liberated here, right? So the first question which is asked to you from this is, do you observe anything happening around the zinc granules? So these are the zinc small pieces. So what are we observing? What is happening around these zinc granules? So hydrogen bubbles or hydrogen gas is liberated around these zinc granules. Okay, this is the answer to the first question. So yeah, next is there any change in its temperature? So yeah, there is a change in temperature. So the change will be that this conical flask will become hot. That means heat will be liberated. Heat will be given out. That means the temperature of this conical flask is going to rise. I hope that's clear to you all. And next part is, why is why is glass tube not dipped in H2SO4? I think you all can see there is this pink color glass tube which you have drawn. I have placed it on the top side. It is not dispersed into the acid. Why? Because see, you know that if we are having one Coke bottle, let's say, I'll draw it. We're having a Coke bottle and we have placed like this, a pipe here. So what is going to happen? The straw, which is there in the liquid, the air pressure is there on it. The air will apply the pressure on the liquid and the liquid will start rising into this. And that is how we suck the liquid out, right? This is how we take the Coke from this pipe, right? So this is how it works. So if we will put it here, okay, I'll just draw it, just give me a second. Let's say this is of proper length up till here. So, if we will draw it like this, just like the straw, we will draw this pipe also up till inside. So what is going to happen? So the air pressure which is developed here is going to push the liquid and the acid will start moving up in the pipe, and we don't want that, right? So that's why the size of the pipe that we are having is smaller than what we were drawing it earlier. Okay, so I hope that's clear to you all why the pipe is not dipped into the liquid which is the acid. And yeah, next part is H2 gas is soluble or insoluble in water. Okay, so now the hydrogen gas which is formed, so will that be soluble in the water or not? You have to tell this. So see, we all know that water is having some space inside it, and some of the gases can be pressurized into the water, like you all know that. The aquatic life is also possible by the same reason, because inside the water, oxygen gas is emerged, right? And because of that, the aquatic animals can take the dissolved oxygen from there, right? But in case of hydrogen, it is not true. So hydrogen gas cannot be dissolved in H2O. I hope that is also clear to you all. And some more additional question I would like to tell you is, if hydrogen gas is a lighter gas or a heavier gas than the air. So always remember, H2 is the lightest known gas, which is explosive. Okay, hydrogen is the lightest known explosive gas. So hydrogen will be the lighter of all the air gases which are present. Okay, I hope that is also clear. And I think one more question can be asked from this particular topic to you is, okay, let me dictate to you all this question. How is H2 gas collected? By downward displacement or by upside? Just give me a second. I will write it for you all. Just give me a second. Yes. So they're asking, the hydrogen gas which is formed will displace the water. If you are collecting, you know that hydrogen gas, because it does not dissolve in H2O, it is always collected over water. Okay, so if it is collected over water, so it is going to displace the water in the downward direction or in the upward direction. This question can also come from this topic. So H2 gas is going to displace water in the downward direction, and hydrogen gas, because it is lighter gas, will move up. I hope that's clear to you all, and this is it for today. Now I will meet some another day with some other great question ahead. Till then, take care. Bye bye, all of you. Bye.